Some time ago, we set ourselves the goal of exposing the fundamentals of physics using a series of resources available to us thanks to new technologies. This goal ended up forged in two massive open online courses, the courses we call the Fundamentals of Mechanics and Fundamentals of Electromagnetism. Now it is time to complete this journey through the world of physics, by focusing our gaze on a phenomenon that we could consider to be transversal to these fields that we have already exposed. And it is a phenomenon that we are basically familiar with. And we could consider something as simple as an everyday experience of standing at the edge of a pond, at the edge of a lake, and throwing a small pebble. What happens when we throw a pebble into a pond or a body of water? If the body of water is initially at rest, we can consider it to be at rest when the pebble hits a point. It creates a kind of disturbance. And that disturbance does not stay in place, but is transferred and transmitted to the elements around it, so that as time goes by, that disturbance becomes contagious and reaches more points. It is a curious phenomenon, because in reality there is no mass movement. The masses remain in place. Yes, they are disturbed, but over time they remain in place. And yet what is being transmitted is the energy. It is the disturbance itself that is passing from some elements to other elements through the medium that propagates this disturbance. Well, that is the fundamental characteristic of wave motion. A motion whose characteristic is precisely that there is movement of energy, but there is no net movement of mass. Indeed, we can find this type of phenomena on many occasions and in many circumstances, and we have talked about the case when we are in waves. The phenomenon taken to the extreme of the waves in a pond are these waves that we find in the sea, and that allow us, among other things, to practice surfing, but we can find in any mechanical movement. And for example, the sound, the fact we can speak and hear, is also a mechanical movement. It is a mechanical vibration of a medium, which is the air. When there is no air, when there is no such medium, then the sound cannot propagate. Electricity is also a wave motion, which we have also talked about in previous MOOCs. Electricity and its propagation is nothing more than an expression of the propagation of waves, in this case with electromagnetic waves that have specific characteristics. Thus, seeing the importance of wave motion, we are going to propose this new MOOC called Oscillations and Waves. The first section will be an introduction to wave motion. We will introduce some definitions, we will classify the waves, we will present the magnitudes that will help us to characterize the waves, and finally we will come to pose the equation that summarizes all this, the famous equation of a wave. And well, as in all sections, we will finish applying what we have learned through a series of examples taken from real life. In the second section, we will focus on the simplest motion, the so-called simple harmonic motion, that will allow us, through its expansion, grow in the complexity of what we study. We will define the SHM, we will study it from the kinematic and dynamic point of view, and then we will see the particular case of the SHM when the damping is introduced. We will also apply what we have learned. In section 3, we will focus on the energetic aspects. We will see that the waves carry an associated energy. They also carry an associated power. They also carry an associated intensity. And from the point of view, we will talk again about the energy and how that wave is attenuated from the energy point of view, introducing the energetic approaches. Section 4 and 5 are going to focus on different characteristic wave phenomena. We will have Huygens principle, we will talk about wave reflection, we will talk about wave refraction, the phenomenon of diffraction. Then we will also talk about polarization, the Doppler effect, and finally we will talk about the superposition phenomenon, in which we will have interferences and standing waves. This is our menu. This is what we are going to present section after section. To help us, as we have done in previous MOOCs, we are going to try to use all the resources we have at our disposal. And this time we have made a lot of videos. We have recorded a lot of videos both synthetic and real experiences. We have also made a lot of virtual laboratories in which you will have the possibility of handling a series of phenomena and a series of parameters. And as in previous occasions, we will have the invaluable help of two great friends, Jota and Amanda, who through their experiences also drawn from real life will allow us to go deepening, and we will see the different aspects of wave motion. As you can see, and as on previous occasions, we have invested a lot of effort but also a lot of illusion. We are eager to start because the journey will be fascinating and we are counting on you. We are waiting for you.